Hello and welcome back to my RC channel. I'm Andy RC and today I'm going to talk you through my cheap custom micro FPV quadcopter build that I have been promising for a while. So the idea of this quadcopter is to be the cheapest possible while using hobby grade parts. So this isn't going to be a toy grade quadcopter with hacked firmware. It's going to be a hobby grade quadcopter that can do full acro and be FPV. So let's start off with the parts. The first part that I'm going to use is the Picnic Quads frame. Now I have used a lot of these in the past. I use the Platform 100X Plus integrated 8.5mm polycarbonate frame for $10.25. Now, you can't go wrong with any of these frames, but this is just the one that I have picked for this build. And I get asked this a lot, how much does it cost? So I've got my calculator here and I'm going to tally it up as best that I can because people may have some parts already and stuff like that. So let's open up the calculator here, and the first thing is the frame, so that is $10.25. So I'm doing this in dollars because I think that's the most universal price that these hobby websites use. Okay, so on to the next component. This is the Ski Sky, or Ski, or Sky. I don't know how to say it. I don't think anybody does. But this is the flight controller board, and it costs $30.88. So let's add that up. So plus $30.88. Now, I have had some problems with this board. I had a flyaway with it, but I only had the one flyaway, and I haven't had a problem since. And it's got a built-in receiver. It works off Cleanflight and Betterflight, so it's going to be my choice for this one. So the next thing that we need are the motors, which I just get off eBay. Now, this is in pound sterling here, but £3.16 is about $5. So you're looking at about $5 for the motors. They're just the normal Hubsan H107D motors. They work fine. You can get more power if you use the Dark Edition motors, but I'm not going to do that. So let's add $5 onto that. So that is $46 so far. So next, this is the FPV video transmitter. It is the FX758-2. It is a really good VTX. It's lightweight and powerful and cheap. Look at that, $11.16. So let's do plus $11.16. So that's $57 there. Next, onto the FPV cam. This is $8 for the cam there. This is the 600 TV line CMOS camera. It works really well. It's got a microphone on it. The VTX actually also has audio input, if that's your sort of thing. I'm going to connect that up, but I'm not a big fan of using audio on these quadcopters. So that is $8.13, so plus $8.13. Next, I only ever use these antennas. They are brilliant. They are $9.95. That doesn't include shipping, by the way. A lot of the other stuff, the shipping is free. So this price kind of doesn't include the shipping, but let's do plus $9.95. Up to $75 there. So next, this is the Pico connector. They're called the SH 1.0mm 4-pin JST connectors. This is to connect the power from the Ski Sky board to the FPV cam and the VTX. And that's about $5 as well. So let's plus $5. So we're up to $80. Which is what I said in my overview. Now, of course, there are other things that you're going to need, but if you already have a DSM-2 transmitter, if you already have your FPV receiver, video receiver, then you're good to go at $80. I think I said $81, so it's not far off there. But if you don't have that other stuff, there are some other options. So for the transmitter, I think the cheapest DSM-2 transmitter is the eFlight transmitter. You can see there that it is £19 there. What's that gonna be in dollars? Probably about, I don't know, about $30, I would say. I think you can get them cheaper in America. This is the LP5 DSM transmitter. I don't think they're a full power transmitter, so be aware of that, but you can get them for really cheap. Also, you can use these park zone transmitters here. Again, you can pick these up cheaper off eBay, and I don't think they're full power either, but it's going to work with the Ski Skyboard. It's DSM2. And let's have a look what we've got next. So you can buy one of these two, which are quite cheap. This is the Spectrum DX4E. It's only 4 channels though, so you'd be flying in just the one mode, acro or whichever, but I only fly in acro these days anyway. And of course, if you want to spend a little bit more money, we've got the Devo 7E, but again, this one has its power limited. You can do a mod, which means that you have to desolder a little diode or short a little diode on the module that is inside, and then you can get a full power, or you can use a Devo 8S module. I did a modification on the channel on how to get full power out of the Devo 7E. That's your other option. And if you have a Taranis already, which is what I'll be using, they are pretty much universal in the hobby. Taranis, I love mine, it's great. You can use these DSM2 modules with it, which I have here, and that's about $32. I'm not including this in the price really because, you know, I could start saying, well, you could take this transmitter and, you know, this FPV gear and things like that, and, you know, the price could be different. Your bottom end price for the quadcopter is $80. And all this other stuff, that's going to fluctuate depending if you already have a transmitter. For me, I already have the rest of the stuff, so this thing is just costing $80. So next for the battery, I am using these Hubsan 500 milliamp batteries. I also use the Nanotech 750 milliamp battery as well, but if you want to get a bit of punch and a bit of power, it's good to use these. You'll get about a 5 to 6 minute flight time with one of those. The propellers, I've got loads of these again, but if you are building this from scratch, then you will need some of these. These are the Hubsan propellers that I'm going to be using. Now, if you don't have a pair of goggles, I think I would go for these. These are probably the cheapest all-in-one option. You can buy the Quantum V1s, which don't have a built-in receiver, but these do, and that's $65. I would go for something like that. However, I'm going to be using my Fat Shark Dominator V2s. You can't buy these anymore, but in my opinion, they are the best version of the goggle that are out there, or used to be out there. They've discontinued them now. The V3s I don't like because they're a 16:9 aspect ratio, and the HDs I don't like because the corners are blurry. One thing you are going to need is a connector that you can connect your battery to that is going to power the flight controller. I use these Hubsan charging cables and I just clip the end off. Those are $3. So there you go, that is all of the components that I'm going to be using, and your other options as well if you want to go uber cheap. So before I start the build video, I just want to address something. So if you're watching this video and it is your intention to criticize my soldering iron, which is old and dirty, or my solder, which is leaded 6040 by the way, but it's a few years old, it probably could do with replacing. Or if you want to mention that I'm not using flux, or I have a rubbish technique, or I should be using helping hands, then this video isn't for you. I would suggest you stop watching now, because I'm not calling myself a professional here. I build quadcopters and I have fun with it. Yeah, sure, there's better stuff out there, but this is what I do. If you don't agree with it, then that's fine. You can make your own video on how to do soldering, but this is how I do it, and this is how I have success at it. So I hope I made myself clear there. Let's get on to the build. So starting with the flight controller, and I'm taking the Hubsan charging cable there and cutting one of the lossy connectors off, and then stripping those wires, And this is going to be our battery cable to the flight controller. Those are nice silicon wires there. So this is the voltage wire going in. Just twist the top over to keep it in place, and then get the soldering iron and dab some solder on there, and it will flow to the pad. Same with the negative wire. Apply the solder and it will flow onto the pad, and we'll have a good join. Next, I'm tinning the 8 solder pads for where the motors are going to connect. I just bridged one of them there, but I just dabbed the soldering iron on it and it unbridges it. A lot of people are afraid of soldering, but you don't need to be. So same again on the other side, just tinning those up. Now I'm taking a length of 3M tape and I'm going to measure it against the flight controller and just cut a length off. I should use scissors here, but the cutters were all I had at the time. I can do a neater job with scissors. I'm then going to place that onto the back of the flight controller. Now this 3M tape, it doesn't look like it sticks very well, but it actually takes around 24 hours to adhere. So I'm going to peel the backing off there, and it looks like it's not stuck. But that's a good thing because it means you can move it around. It's not going to stick instantly. For example, here, you want to stick this right in the middle of the frame. However, because I'm looking through the camera at the same time, it's slightly off. So once I place it on, I can sort of shift it around until it gets to the middle. Next, I'm going to temporarily put the motors in. Those just tension fit into the picnic quad's frame. Can take a bit of effort to do that. I'm going to do that for all of the motors because they like to stick together with the magnets inside them. Makes the soldering easier. So now I'm measuring up the first wire, making sure that it will reach the solder pads, and then cutting those wires off. I'm then going to strip those wires and tin them. Now flip the board around and I'm soldering in the first blue wire and then the red wire. So onto the second motor, I have measured it out again and clipped the wires shorter and stripping them and then tinning them. And soldering those in. That's the first one in and the second. So I'm measuring up this wire again, making sure that it reaches and clipping it off. And stripping the wires again. And tinning the wires. And soldering them to the flight controller. Now, the last motor I'm measuring up, unfortunately, the camera cut out when I soldered these wires to the board. So what I did was I zoomed in on the flight controller once I had done it, just to show you all the connections, because you can probably pause the screen, and once you know the technique that I used, you can just go ahead and look at the diagram and solder them. So this is where it cuts out, and here is the final piece with all the wires connected. So this is the Pico connector, and I'm removing the red and the black wire by sticking a pin underneath. The reason for that is the yellow and the green wire are in the position of the voltage and negative. I didn't want to remove the red wire and replace it with the other two because these connectors break really easily. So I'm stripping these wires here, but in this case the yellow wire is voltage and the green is ground. So I've taken the camera and I have cut that to length, making sure that it reaches the front. And now I'm tinning up the wires. And then I'm tinning the VTX. So this one is the ground, and this one is the voltage. So that is the voltage into the camera. And then I'm going to take the yellow wire, which is going to be the voltage in from the flight controller. And that is going to piggyback over the top. And the green wire is the ground. And the black wire is the ground, which I'm tinning up for the camera. And again, I'm going to piggyback that on the top of the green wire. There is a spare ground pin, but it's very close to the audio pin, so I'm just putting these two in at the same time. The next two pins, this one is the video and the other is the audio. Solder's in the way there, but you'll see it in a second. So this is the audio cable and the video cable. So I'm putting the audio in first. Even though I don't really use audio, I thought I'd check it out. And finally, this is the video going in. So I'm now going to tin the antenna wires. So the middle pin is the signal and the outer two are ground. This is just going to give us the one channel, by the way, unless you short any of the other ground pins. So I'm now clipping the middle pin of the antenna, and that is going to fit on like this over the top. And just solder in that center pin first, but of course we need to tin it first. So solder that into the middle to keep it in place, and then solder the two outer ground wires. Just add a bit of solder to all of that area as well, those two ground wires, and that keeps the antenna sturdy and it won't bend. So that's both of those in. Then I'm cutting off the excess underneath. Then I'm taking the motors out and I'm going to twist them. Just keeps them neater. Twist them all the way to the flight controller, make sure that none of the wires come loose. And then with the Picnic Quad's frame, you get these little tiny rubber bands, elastic bands, and they can fit over the arms. And that keeps our wiring all neat. So next I'm taking some more 3M tape and cutting a short piece off. The great thing about this VTX is it's completely flat and it sticks to this double-sided tape brilliantly. and that will fit sideways so that the antenna sits in the middle so that the props don't hit it. And it just about gives you enough room for the USB on the flight controller. So press that into place, and again, 24 hours to dry properly. So now this is the cable that connects into the regulator. I'm just going to push that underneath the frame to keep it tidy, and that is going to plug into the side there. And then we just have the camera. So I've bent the microphone back slightly, and I'm applying hot glue. I'm going to put a slight angle on the camera, but not too much, because I want to be able to fly this indoors. So I'm just tacking it with hot glue and making sure that it is straight as I can get it. You have to be quick with hot glue. And then once I'm happy with it, I'm going to fill the sides in, and the camera will be secure. And that concludes the build part of the quadcopter. So I'll talk you through my Cleanflight setup. You're going to want to put this on a flat surface here and calibrate the accelerometer. In ports here, you want to make sure that serial RX is ticked there on the UART2, but don't tick UART2 here, and you want to make sure that you save and reboot when you change any of these settings. Under the configuration tab, we've got Quad X, I've got motor stop on, and I also have disarm the motors regardless of the throttle value when using an auxiliary channel. That means you can just stop the motors by disarming. The motor stop feature here means that when it's armed, the motors will be stopped. So for the receiver mode, we want RX serial, and then we want Spectrum 1024 down here. I don't think we need any different settings on there. Oh, also these disarm the motors I have set to 5. That's just the number of seconds before it disarms after it doesn't receive any input. If you lower that, it becomes really hard to take off. If you set that to 1 second, then you have to be really quick on the throttle when it arms. So yeah, I keep that at 5. Minimum throttle I've got at 1080, mid is 1500, and the maximum throttle is 2000. Make sure that you set that to your transmitter, otherwise you won't get the full amount of power out of your motors, and I'll show you that in a bit. So the failsafe, that is when you turn your transmitter off, and whatever value this reads here, when it's off, you want to lower it than that. So I've got it set to 977. PID tuning, I'm using the Lux Float. I believe the Multi-Wii latest is probably the best, but I found that the last time Lux Float worked for me the best out of the box. So these are my PIDs here. My rates I've got at 0.6 for all of them, not using TPA. The receiver, I am connected with my Tyrannus, and you can see there that my minimum PWM value for the throttle is around about 1000, just a little bit below, and then max is 2011, so I'm getting the full range of the power there. Same for the roll, you see there our minus PWM value is 988, and the same for the opposite. And you want to make sure that everything is in the middle at about 1500 or so, which it is. And then I've got my aux channels here for the different flight modes, and that's my ARM channel aux 2. So talking about the modes, let's go in here. Now I don't have any modes at all. I'm actually arming with the rudder, and I'm just flying in acro mode. But let's just say you want to arm it on a switch. You press add range here, and I think my arm switch is actually aux 2. So you can see this little green thing here. So if I set that over here. So it'd be armed now and not armed there. So that's how you set that. So I'm going to save that. Why not? Let's have it on a switch instead. I just haven't set it up. Angle mode. So I've got a 3-position switch here. You can see there that it moves. So I like to have it so that my default mode is acro. So if we say angle mode is going to be in the middle, like that, and then horizon mode, we can do the same on aux1 and have that there. So if I move this across, like that, so 0 will be acro mode, the next one will be angle mode, and the one after that is horizon. So your angle mode is your stability mode, your horizon mode is stability mode, and it lets you do flips, but it kind of self-rights itself. And then acro mode is just full acro. You have to control when the aircraft sort of levels itself. One thing that you need to do in the CLI is you need to set the PWM rate to 32,000. I've got this copied in here already. You can see set motor PWM rate equals 32,000. Press enter there, and you also have to then press save, and the thing will reboot. If you don't do that, then you'll probably get the motors spinning up when you plug the battery in, which isn't good. And also, to stop doing that, you're going to want to have one shot 125 disabled, and you should be good.